This is session number 9. And if all goes well, we'll have 10, 11, and 12 later on today. Actually, as I look at the schedule for today, we're talking about things that are most system dependent. These are the things that are of most concern to the people in the audience, I imagine, because they're the things where you're going to have to be responsible to make it work on your own system. On the other hand, the percentage of things that I have to cover to the things that are in the book is much higher, which means that I can go slower today. Yesterday I was taking huge parts of TeX and just waving my hands and say it does it sort of like this. Today we're taking small parts of TeX, the small system-dependent parts, and we can go over them slowly and leisurely, make sure that everyone gets a thorough understanding of what's involved. And file names is the agenda for this hour. Starts in module number 428. I think we'll be able to keep the lights on all hour, as far as I know, is for the TV people back there. Now, here we're getting into the subject which makes portable software the most difficult, because different operating systems differ in the way they want to refer to file names. I thought once that maybe we should just say that as someone's writing in TeX and wants to say input from a file or name a font for some file, that TeX should have its own language for file names so that it could be independent of systems. But there was just no way that I could do this and make it right. A person who's using TeX as one of his or her favorite tools on the system will definitely want to call file names by the same conventions that are used for the other programs that are used on that system. So we have to live with the fact then that there will be programs written in TeX that are going to include syntax that isn't going to be parsable on other installations of TeX, just in this place where we refer to names of file. There should be something that works everywhere. Namely, if we have a file that the name is entirely composed of letters, then every version of TeX should be able to do a reasonable thing with it. So I mean, if someone says input paper should refer to some file called paper that I think we'll be able to handle on all installations of TeX. The strange thing happens that what if it's somebody else's paper, and so we have to say input SE for somebody else paper on one operating system, or we have to say paper SE/paper on another system, and paper bracket 1, SE on another system, and so on. And there's lots of other different kinds of bracketings and things that are used in order to locate things in file servers and on networks and various things. Then it's going to be different everywhere, and it depends on the system-dependent version of TeX to parse these names and to come up with something sensible about them. Now, but I want to try to have a little bit of uniformity in all of this, and so I tried to write TeX82 in such a way that the system dependency would be factored out into a small number of routines that could be called in a system independent way. This is an attempt then to get as much portability as we could, given the fact that we couldn't be completely uniform across all systems. Now, I'm sure that if I interviewed the people in the audience, I'd get another longer list of possibilities. Certainly, I see the guy from MIT right here, and they have a really strange bunch of conventions. Okay, now we can talk about, for example, on their system you give two names separated by spaces and then paper. Is one of the ways to work it on that system. And one of the things TeX likes to say is that a space is a delimiter after a file name. So if the name of the file is going to include spaces, then they should put quote marks before and after, and take spaces out inside of there, for example. Some kind of a scheme like that should be implemented, but it should also be consistent that somebody who does this can be comfortable with the idea that it'll also work at MIT even, and all the others. The reason that MIT and Stanford tend to be more different is because they started first, and the conventions persisted over many years. And the reason this whole thing is in such a mess is because computer scientists haven't considered that file naming was part of real computer science, and never really paid much attention to the problem. It was always left off as being something for hackers or something, and it was never, but it was never considered as a scientific problem. And so we have this proliferation of things. The same applies to almost as much a degree, just all input-output in general. Computer scientists have tended to work on what you do inside the machine once you got it in there and before you put it out. But input and output never was given a very clean solution in languages like ALGOL and so on, where the best language designers have really sat in committee meetings. They just didn't tackle input output. Because they didn't somehow it didn't meet their taste for what was an important problem at the time. It should have been, but it didn't. So we have this problem. Let's see how we can approach it. Now the thing that TeX82 wants to impose on is at least one kind of thing that a file name consists of three parts. It consists of the name part, paper, and it consists of an area part, which indicates what area this might be on, what location within a large file directory, and there's an extension part. Now, it seems to be true that when using these systems that we've been talking about, it makes sense to have related files. And in the systems we've been using here, we relate the files by giving them the same name but different extensions. So a person running paper would write a file called paper.tex, for example, and then he could expect, as a result of his run, to get paper.dvi for his output, the DVI file, paper.err for the transcript file of his session, containing his error messages and more information, diagnostic information. If somebody has a font called basic, a format or macro package called basic.tex, and you input that to any text, you would expect to get out basic.fmt for the format. When we write a program in web, TeX, we have tex.web, tex.ch for the change file. We compile that into tex.pascal or something for the Pascal file, and tex.pool for the string pool file. Some kind of this idea of having a family of names with extensions on it seems to work reasonably well with other operating systems, and it could be, you don't need a dot for that if you don't like a dot, but In the examples in the TeX manual, we're going to use a dot to indicate that. Now the area is the or file directory or whatever you call it, telling you how you get there. If it's not specified, you have some notion of a default area. For example, whatever the user is logged in under is used as the area. But at every system, you have some natural idea as to what that's going to mean for the default area when no area is mentioned. And when it is mentioned, then it might even be partially defaulted and so on. There's a variety of conventions for that. Let's talk about fonts also. Here I've got a format file. Here I've got a paper file. What if I have a font? F is say the name of a font. Then when I'm running metafont, I would have ff.mf for the metafont source file. And it would produce lots of different kinds of output. It might produce ff.dvi if we're doing proof mode. And ff.pxl for the bit image of the font. ff.tfm is the one that concerns us. The TeX font metric file, this would give the information to TeX. And a variety of other possible things. ff.chr is what we're using for files that can be edited so that you can play with the pixels yourself at low resolution. Okay, so this idea of extension is there. And we also have the programs TF to PL and PL to TF I'll be talking about later today. So you could read the FFTFM file and convert that into FF.PL. So for a variety of these things, we seem to see that we want a name of a name and then an extension telling what class of file relating to this name is involved. Now, slight difference exists though between font files and these other kinds of files, because usually the fonts are something that that their home is in the system, while a person's paper is on his own area. So when you specify no area for a paper, it means your own login area. If you specify no area for a font, it means the system font area. If you want to use a font that's only your own, that you just made yourself with Metafont, say, then you are supposed to really specify your own area specifically in the case of fonts. Because if you leave it blank, that's going to mean the system font by that name, unless there is no system font by that name. It would look first for the system font. And I think that we have to realize that these are different. So TeX is using that assumption now that if the area is blank, it means a default area of some sort, but the default for fonts is the system font area. The default for other things is the user's logged in area. Okay.
If on a file name for...
Where are you? Okay.
If on a file name for a TeX source file, we omit the directory and it's not a directory specification and it's not in our area, does it look in the system area afterwards, as it used to?
Yes. Yes, that it's built in right now that we have a default area to look before complaining that we couldn't find the file at all. So it looks first on your area and then it looks on a system area. We'll see that later on this hour. I think I'll get to that. And this could be extended to look in to go through a sequence of other areas before giving up and saying, I can't find your file, please give me another name. But right now, the code does support one extra try on after /input. Okay, good point. Now in in the case of font files, we have to communicate the file name to the DVI file. So after we get this, after TeX has read in the font file, then the DVI file is going to have to contain the name of that font for communication to the outside world. And so the name of the font is given by giving its area and its name. And both of those are sequences of ASCII codes. So in the DVI file specification, well, we'll see it later, but it turns out that the area, which is usually empty for the system fonts, and the name are given as a sequence of ASCII code, or more precisely, TeX internal codes, so that the font name that you use comes out in a DVI file without the extension, without a TFM, without any extension whatsoever. Okay, now how are we going to do this? I tried once to think of a scheme that would encompass all of the world's naming conventions for files, and then I would parse. I would parse this, and I would have a universal except MIT. I left out MIT. I had every other possible scheme of file naming that I could find. And then I was going to define the syntax for this, and then put it all into a thing, and then let the system-dependent parts just look at this, or maybe even work it on all systems. Well, that was a failure. It couldn't be done. So instead, I said what I'm going to do is I'm going to ask everybody to write 3 procedures that are explained there in module 429, begin name, more name, and end name. And when TeX comes to a point where it needs a file name, for example, it has just passed the keyword input, or some other place where it needs a file name. There are more than you might imagine after fonts and so on. Then it will start, and it will call the procedure begin name. Suppose somebody writes input, and then after that he has a sequence of characters, C1, C2, C3, and so on. This is after a macro expansion. So TeX will then supply tokens characters actually to these things. More name takes in C ASCII code, TeX internal code symbol as a parameter. But begin name and end name don't have parameters. Okay. Now what TeX is going to do? Oh, by the way, this also returns a value. So this is a function that returns a Boolean value. TeX will first call begin name, and then it will get the next character of the input and expanding macro if it was there, and if the next character is is a TeX primitive, something like def or something like that, then TeX will immediately call end name and say that we've got to the end. If it's a blank space, TeX will also, I believe, call end name right away. But if it's a character, then it will call more name of C and get a value back, true or false. More name is going to return true if the name hasn't ended yet. As far as it knows, that this needn't have to be the end of the name. But more name would return false if this is definitely the end of the name, and TeX should stop. And TeX should call end name immediately afterwards. And so we'll keep calling more name, more name, more name until we either get to something that TeX thinks is the end of the name, or until more name says false. TeX thinks it's the end of the name when I get to something that isn't a character, or when I get to a blank space. So this means that, for example, at MIT, if the first character of the name is a quote mark, then more name would return true until it got to another quote mark, and it would tell TeX that it was false. For example, this is a way that the logic of calling these three procedures would be the same on all systems, but the three procedures themselves be different. Now, after this is all done, an end name has been called. Then what's supposed to happen is that we're supposed to have three global variables have been set up called cur area, cur name, and cur ext for the area, the name, and the extension. And these are string numbers. These are pointers into TeX string pool, giving what those areas are as a string that could be printed out in principle. So these are the result of end name will be those three areas, those three things. And they're all strings in the sense of TeX strings that we talked about a couple days ago. If one of the strings that you can have in TeX is the null string. Pascal compilers don't always allow null strings, but if the null string is one of the ones that TeX has in its pool, and that would be used if the area is blank and the extension is blank. So if Sky just writes paper here, cur name should be the string paper, and cur area and cur ext are blank. That's the one thing I want these to satisfy. The other things are dependent on what you think is appropriate for your particular system. So, for example, if this I had DEK paper here, and I was using a TOPS 20 system, then the program would call begin name. Begin name would set some kind of initialization so that it knows what it's doing. These three procedures typically will communicate among themselves with global variables. And then I'll call more name of less than, more name of D, more name of E, more name of K, and so on, more name until I get to more name of R, and then I get a space and I wouldn't call more name anymore, I'd call end name. Or if something besides, like a backslash input again comes right after that, then I would again quit. Okay. Now, in order to illustrate that, the program assumes a special kind of syntax that is typical of other ones, but it's one that was close enough to something I was familiar with that I could do. And so the example of how to write begin name, more name, and end name in these sections are based on a simple simple scheme that's defined in module 430. And here's the scheme that I proposed there. If the name contains a greater than sign or a colon, the file area consists of all characters up to including the final such character. So if you had several colons, several greater thans, and so on, only the last one counts. Otherwise, the area is null. Now, after you've thrown away the area by this rule, then you look for dots. And if there's several dots, only the first one counts. Not the last, but the first one counts. And then the extension would be every character, including that first dot, to the end. Otherwise, the extension is null. So that's the proposed example that's used in the program, and in order to implement that, I did that by having two global variables called the area delimiter and the ext delimiter, and this would just be a place in the string pool where the most recent or relevant delimiter has occurred, either a greater than sign, a colon, or a period. So we have in our score system, for example, in order for me to refer to paper, I would have to say CSD.DEK paper, and I could also say .tech.2 in order to refer to version 2 of the paper. In that case, this would be the area, and this would be the extension. Because I pick up the first period, but I don't count the period that's in there. Okay, now how does more name implement that? Well, it's simple. It has a pointer to the most recent greater than sign or colon, and a pointer to periods. And so it starts putting in the string pool a left arrow. Let's see, let me give myself another board here. So I'll have my area delimiter A and my X delimiter E, and initially they're null. So I put in the string pool the first character less than, and a C, and an S, and a D, and a period. Well, this looks like the external delimiter should be a period, because this might be the extension coming up here now. D, E, K, and a greater than sign comes along. A greater than sign says, uh-oh, this is an area delimiter, so I'm supposed to remember the final greater than sign. And so that comes here. Also, I wipe out E at this time, because though they don't count if they're in the area part. And then it would say P-A-P-E-R dot, E starts to point there. If I got a colon now or something, it would wipe this out again. T-E-X, period. Now I check, with this period, I check that this guy is already non-null, so I don't change him again. 2. And then end name is called. Now end name has to figure out from the fact that A is pointing somewhere and E is pointing somewhere that that this string here is supposed to really be broken into 3 strings. And so I think the code does that. And it makes up 3 strings in the string pool according to the conventions of the string pool. So that string start of cur area would be here, string start of cur name would be here, and string start of cur X would be here. Okay. So these 3 programs you need to write to do the right thing for your system. Now, we also have to figure out how we're going to open files that are there, and Pascal doesn't give us Pascal was really intended more for small, self-contained programs when it was designed, but it's been always extended now so that it's possible to, on every Pascal I know of, to say reset, and then you say file name, and then you have some file variable, this is, in your Pascal program. Then you have some way to say what file you want to open. So let's suppose that that we're working with Pascal that allows us to put here, like, name of file, okay, paper. Now, let's suppose that this string has to be of a certain definite length. It depends on which Pascal you have as to what happened. But anyway, you should be able to specify the name of some file that you want to input to the system routine for resetting. If you can't do that, you just can't possibly use TeX, because TeX has to be able to read from files that aren't known at compile time of the Pascal program. So file variable, and then we have some extension that allows us to do this, either by some system call or something. It's got to be possible. And it is. So now, what about this string here? Well, see, TeX when it does this, it assumes that this string, I believe, is called name of file. I should have reviewed this morning, but that's it, name of file. So we're going to say that this parameter here is a global variable called name of file, and TeX is going to set that global variable, name of file, before it tries to reset the file. And the system procedure that does this is called pack file name, and it's in module 436. Pack file name has three parameters, N, A, and E in this order, and there's string number, which means that, you know, it's an indication of a string. It's TeX idea of strings. So you give it the three strings that you found that after end name, those strings are supposed to exist in cur name and so on. And then pack file name will do it. Now TeX is going to substitute its extension though, sometimes. You see, that's it. So if cur name, for example, is paper, and then TeX is going to want to output to paper.err, then pack file name is going to be called with the extension part set to a string.err. So TeX will, and similarly .dvi, .fmt, TeX will generate other calls on pack file name for other things. TeX is going to manufacture combinations of file names according to this procedure. Okay, now we need. Okay, so pack file name does that and puts into the global variable name of file the thing in the correct format. Now, I don't know if anybody here has a TenX system, one of the old DEC operating systems, but in that case, in order to call reset on one Pascal compiler that I know of, you had to have two parameters for name of file. You had to have a string and a pippin. And the pippin was given in what they called 6-bit code, which was a curiously packed 36-bit word full of 6-bit numbers, and it's the only way the operating system would accept it. So the reset procedure had three parameters, and so this pack file name procedure on such a version of Pascal would have to set two things. One of them would require a calculation of a 6-bit code from the extension in some grungy manner. But this is necessary, and I'm sure that there are even weirder systems in existence that are going to need this. But that's why I put this up as a separate routine and don't consider it system independent. Furthermore, on the better Pascal compiler that I'm using now on SAIL system, I have we put the area last instead of first, and so pack file name is certainly different on this machine than it is on others. So anyway, you got that one. Now there's another program you need also besides pack file name, which is pack buffered name, and this one is not as clean. It's unfortunately necessary because sometimes we're going to have to be getting a file name before the TeX has been able to set up its strings. You see, when TeX starts out, and we've got a virgin version of TeX, it has to read in its strings. It doesn't know any strings. It can't use this idea of cur area, cur name, and cur extension at all because strings don't exist yet. We have to get the format file. So the user is based on the user's input, will know whether there's a format file or not, or to use a standard format file like BASIC. And we haven't got strings yet, so I have to do something special there and get the name right out of the buffer. And so this routine is got different kind of parameters, and N is the first parameter is called a small number. A small number is 0 to 63. it's generally even smaller. And then A and B are also parameters to this thing. But N and A don't match the N and A there, so it probably wasn't a good idea. But these are integers, but also typically small. And the idea is that we're going to manufacture name of file from something in the buffer instead of using the nice begin name, more name, end name conventions that we had there. And this has to be done in the following way. I have a string called TeX format default, and I illustrated it there in module 439 as being something like this: TeX formats dot basic TeX basic format, excuse me. Some string that indicates the default file name that you would use, the default name of file that you would use if if there is no specified file name given. What packed buffered name is supposed to do, it's supposed to take the first n characters of this string, and then it's supposed to take characters A to B out of the buffer. Buffer is something we use for input buffers, for input from the terminal. So buffer A through B, inclusive. And then the last 4 characters of this string, .fmt. That's the way that thing is defined right now. This is a procedure, packed buffered name, that has to be used when TeX is really bootstrapping itself to get going at the beginning of a job. It's not allowed to call error messages yet because the error routine isn't workable. Error routine needs strings. So this is way at the beginning when TeX is just being born. Every time if it's been loaded, and that is messy, but there was no other way. I mean, we had to do something at this point to get everything going. So that routine is called only in module 441. It's called 3 times though, and what happens is this: suppose somebody calls TeX, and he's running a version of TeX, which means that it's not any TeX. It's the one that's used for production, but it could be used, but doesn't have any format preloaded into it. So the next thing that person writes is the name of the format. So if the next thing a person writes is amstech, for example, then it should look for amstech.fmt in some system format area, or in the user's format area. And then you could say paper after that, and then it would be the paper that this would be a way to call it. If you can't support getting this on your command line, this would be given to the double star prompt that you would get right afterwards. But in any case, the first thing would be the format file that's to be read in. So it's sitting in the buffer, because this has somehow gotten into the buffer, and TeX will know where this thing starts in some position in the buffer, some subscript in the buffer, and it'll know where it ends in the buffer. It looks for a blank space for this purpose, I believe. Yeah. Now, so format names should be given. At least that's the assumption that we're making here. And it seems to be reasonable for all the systems we knew of. Okay. Now, so what does this module 441 do? It looks first to see whether he's got a backslash. This might also be relax, or some other primitive saying that I don't want, I don't want you to input any file, any source file. If it's a backslash like this, then we're going to assume we got the basic format that we're going this default one going to come in. So let's suppose it's not a backslash. Then we look for this .fmt. Pretty sure that's exactly. If you first try without the system file area and with the .fmt, so we call pack buffered name on this whole on this thing, but with n equals 0, so we don't pick up any of the first part. And so it'll look for amstex.fmt on the user's on the user's area. If it doesn't find that, then it tries next with the system file area. So then it sets n equals some number that's the number of strings to use. It's called format default length. Format default length is n, and the next time, so it'll try for tech.formats amstex. Should find it then. But if it doesn't, then it pulls out all the stops and uses this whole format default name. Sets A and B to something like 1 and 0 or something, so that you won't pick up anything off of the user's area. And that would be the normal case. The normal case is that there is no specific format given here. It just has the name of the person's paper. And so it won't. So it would pick up the system area, and the user wouldn't have to know that there was even a chance to specify another format at that point. Yeah, question?
Yes, why do you use the backslash to return a C character there?
Sorry?
Why are you using the backslash instead of return a C character, which may not be the backslash anymore?
Yeah, the backslash is always assumed to be an escape character. It's the only character whose type is known. But in TeX82, we're starting out assuming that backslash is an escape character as an assumption. This means really the code whose internal TeX code is octal 136. It doesn't have to be visibly a backslash, but it has to be the character that's internal code is one. At the code table initially understands letters and that backslash. This other idea that we had in TeX, in the present TeX, that the first character you type in is going to be your escape character, sounded good to us at the time in 1977, but it's caused no end of confusion ever since. There were great sighs of relief when I told my group that we were going to assume that we know that it's going to be backslash. One of the most funny examples of this in the other case of TeX was when a novice user approached TeX. It gave the prompt of asterisk, and the type in was paper. It seemed a reasonable thing to do compared to other systems that were there. Well, so P was the backslash character. P was the escape character. So then it had a macro, PA, because this escape character terminated it, you see? Well, that's backslash A, that's an accent. And so it said, whoa, you have to define a font first. This was a very scary first encounter with TeX. Now this is going to work, and we found that I think most users wanted that. So if you have some other character that's going to be the standard escape at your system, you just publicize that in the manual, and everybody will be glad to use it. But this changeability of the escape character was not a winning idea, so we're dropping it. If somebody says TeX, also the manual is going to say, how do you run TeX? And so it's going to say, well, you give the name of the file that you want, or if you're going to do some simple experiment with it, you say backslash relax. You could say backslash input paper, wouldn't hurt. But if the first thing that you type in is not a backslash, it essentially implies that it was backslash input. And if the first thing you type in was not the name of a format, it assumes that it's going to be the default format. We wrestled around with lots of different possible strategies, and this one turned out to be the one that seemed to satisfy all the requirements as well as anything. I think it's going to work well. Okay, so pack buffered name is this routine that has to be used in order to get the format going at the beginning. It's only used in that one place, and so if you have to do something special for your system, you just have to do it at that time. Okay, now let's see. Module 442 talks about something that we'd like to do if you can, but it's not necessary to make a change here. And that is figure out what's the actual full name of the file that you have just opened is. So for example, if I'm writing paper.dvi, it'd be nice if I had a system call that would say that this is actually paper.dvi versions 28. And so that on my transcript file, it will tell me that I have just written this one version 28 so that I can tell which it was. My transcript file will have a date and time on it if we've been able to implement that part, but it was also nice to correlate that with the actual file that you've written out. So there are calls, it's called jiffins on TOPS 20, and there's various ways to get at hidden things on the SAIL system, and I'm sure VAXA has different calls. This other operating system usually have a way to say what is the exact full file name that I have just opened. You have a question?
Yes, if you have a system that doesn't allow multiple versions, you recommend automatic scratching of old versions, or?
That's what we have. Yeah, that's what we have. In fact, even on a system that allows multiple versions, they tend to fill up the disk very fast, and if you're paying for it, you pretty soon set that as your default. Although I have seen in other places where I wasn't paying for it, like when I used the free services at Xerox, sometimes I had run up about 210 versions of errors.temp at one point before I ran out of memory and had to go back to my recent version. But no, they accumulate very fast, and it's nice to have, but it's a luxury. The system that I use every day, I get by with only the most recent version, and only twice a year do I go through fits of anxiety because I just clobbered it, something that I needed. Anyway, if you're used to working on that kind of a system, you learn how to protect yourself against disasters most of the time. Yeah. But I don't know. Just not everybody will agree with these things. But anyway, we got this make name string function, which is supposed to take either the file that you've just opened and find out what it is. And so we give the make name string. I have three functions defined there: A, make name string for an alpha file, B, make name string for a byte file, and W, make name string for a Word file, only because in Pascal I had to have a type associated with a file name, unless I'm writing a system procedure. And these would return a string that gives me the full file name. Including, like in our system, it would tell me that I found one on the system area, if that was the one that was actually being input. If you can't do that, you could generate it just from name of file. But you're supposed to generate a string like this a couple of times for error messages and for historical records that TeX makes. I guess I should mention alpha file is a file that corresponds to text, like your source, like your .tex files that you're inputting. B byte file is a file of 8-bit bytes, like a TFM file or a DVI file, and the Word files are the .fmt files, the format files that are made out of memory words that we store and retrieve for initializing TeX.
Is there some particular global that make name string is supposed to return the name of?
Make name string returns a string number and it's given a file variable as its input. So the idea is if f represents a channel, or some, if f represents a channel in DEC jargon is similar to file variable in Pascal jargon, whatever has just been opened on that file, we should create a string in TeX string pool and return the number of that string.
So will you always be calling one of the typed versions of this? Is that what you're saying?
Yeah, I always call one of the typed versions, right? And by looking in the index, you'll see that it's only called about twice, But there are those times when I do want to know the name of the file that I've just opened. For example, when somebody says input paper in the sales system, and we saw that in the demo the other day. So what actually came out of the left parenthesis saying I'm starting to read a file, and then it said paper was capitalized, paper.tex. That was the default extension applied at that time. Left bracket I think whatever I was logged in under, I think it was pass DEK, was there. That was printed out. And that full name was supplied by my system-dependent a make name string. This code starting in module 444 here is supposed to be independent, system independent, not requiring any changes by you guys. And so it summarized the way we should have done this: begin name, more name, end name. This is the driver that calls that. The driver is also called somewhere else, where it pulls the characters out of a buffer. And when you're declaring fonts, that's in the prompt file name routine, which again is supposed to be machine independent. So the rest of this section it tells about the things that ought to work everywhere. A few of them might be marked system dependent, but I don't think so. So the critical problems about the timing of these things, fitting it in with all of TeX input and output routines, getting it to going in the right place. I think I've done that in a system independent way. All you have to do is these routines that are defined without knowing much of the logic of TeX. You just have to. These are system problems. I tried to factor out the TeX algorithms, the thing-specific TeX, into and leave you just with comparatively simple tasks: begin name, more name, end name, that don't depend on the fact that TeX is also writing paragraphs and has even that you don't have to know that TeX is going to be prompting the user to give you another one if you can't find the other one. I mean, that logic in prompt file name is supposed to work in all versions of TeX. You want to look at prompt file name a minute. That's module 448. It has two parameters. One of them is descriptive of what kind of a file it wants, and the other one is the default extension that it would apply. And it either says I can't find file paper.tex or something like that, or it says I can't write on file paper.tex. See, print file name is a system-dependent procedure that I neglected to mention. It must have been in one of those. It must have been. Oh, yes. On module 435, I didn't mention you need a procedure that takes 3 strings as input and it prints them out as a name that might have produced them. That's such a simple procedure, a short one, I forgot to mention it. So print file name is one you got to write also, unless it's the same as the one there. So it prints out the name that it can't find, and then it, if the extension is .tex, it shows the context of the message. In the case of send files, and in the case of input files, it was appropriate to show the where the file name appeared in the person's input. But in the other cases, this was a file name that was manufactured behind the scenes, and the context wouldn't make sense. So that's why it doesn't show context in the other cases. But show context is a subroutine that prints out these two-line indications of where you are in your source file on an error message. Then it'll say, please type another S. Please type another input file name. Please type another output file name, something like that. It looks next to see interaction. That's one of the things that TeX has. It's 4 levels of interaction. There's batch mode, non-stop mode, scroll mode, and error stop mode. And if the interaction level is either batch mode or non-stop mode, then you're not supposed to ever mention a file name that couldn't be found. So your job is aborted at that time. Batch mode, for example, is intended for overnight running. And if you can't find the file at that time, you're dead. There's nothing to substitute for. But otherwise, if you were in scroll mode or error stop mode, then you get a chance to input a new file name. In the first 2 cases, it would have at least told you what it couldn't find before it died. Now, let's see. So then it clears the terminal. Clear terminal means show, in case the user has been typing ahead, cancel what he's been typing ahead. That's a system-dependent thing you'd have to do. Some people think they know what's going to go on, and they start typing away and save themselves some time. But in an error like this occurs, then they don't want what they typed ahead to be considered the new file name. So we clear that. We prompt them and scan the file name in a buffer, which is the next module that is another call on begin name, more name, and end name. The prompt input routine gets something from the terminal and puts it in the buffer. After we've got the file name in it and we've got an empty extension, we use E as the default for empty extension. We pack the current name. That's a macro call explained there that calls pack file name with the current name, cur area, and cur extension. So that's the logic there in prompt file name. That logic you shouldn't have to change. That logic was is something that knows about the rest of TeX. The other routines that I've mentioned don't have to. One more point I want to make before we close, before I forget it, and that is this reset procedure here that opens a new file. It's not only supposed to be something that is able to open another file, but it's supposed to be. It's not supposed to give us a system error message in case it couldn't find the file. And otherwise, you will have to change TeX logic. So I want to explain that. Or similarly, rewrite is another one where you have a file variable and a name of file, where you're trying to open or get ready to write on a certain file name that you've generated in your program. Now, I have procedures called open. A open, B open for alpha file opening, and B file opening. But and they're going to return true or false based on whether or not they were successful in opening this. But they call reset and rewrite. And you need procedures, reset and rewrite, that are going to let you that are going to let you know whether that file was there or not. And the way Hendrix Pascal does it, I think, is the best solution, and that is you look at EOF at the end after you've done a reset, and if EOF is false, then you were successful on opening this file. You found a file for input because you're not at the end of the file, and for output, if EOF is true, you're successful. You've successfully gotten that file ready for output. But if the opposite holds, so if you tried to reset and you found that EOF was true, this is what this says. The file wasn't there. And if you tried to rewrite and you get a false EOF, you're not in the file. This is your clue that the file wasn't there. Now, if on the other hand, if you're using a Pascal runtime system that's real smart, and it says, oh yes, I couldn't open this file, so I'm going to ask the user for a file name myself. Well, then the user might get an inscrutable error message that isn't tied into the TeX system. But then but that's not the worst of it. The worst of it is that the reset procedure will always return this condition, and so TeX will always think, no matter what the user typed, that it was okay. So, for example, you misspell your file name, then it appears in the error message. Say you didn't know what you were supposed to do. You typed a question mark. And TeX will then call to open the file question.tex for input. Okay. Well, the Pascal runtime routine will try to open question.tex. It won't find it, and it says, it'll say something like file not found question.tex, new file name. What should it be? So you type in a new file name. Oh yes. Paper.tex, and it finds it. But then TeX is going to look at this question mark and think it was okay, so it's going to try question.err for the transcript file, and it's going to try question.dvi for the output file, because TeX didn't have any indication that anything went wrong, and so you're going to have to type all those three in also afterwards. So we want to use a version of reset. We want to make sure that this reset gives the information and the chance to make error messages to TeX, and doesn't try to do it all itself. If not, you have to think of some other way around that. Okay, now, so that finishes our first hour and 5 minutes. Is it quick?
Yes, on some systems that do that, you might still be able to find out the name of the file that was opened.
Oh, there would be a way out probably, but you will have to get into some of the logic of TeX in that case, and work a little harder. Right now it's set up for under the assumption that we are able to have a procedure open that will be able to return true or false as to whether it was successful open or not, and we're trying to give a good indication of what files we couldn't open. Since you asked that question, it reminded me you had asked earlier a question about the TeX, the standard area, and what happens when you type \input. So if you want to look that up, that's module 454, where the file for input is actually opened, and the calls unpacked file name with a TeX area. That's a macro defined to be the standard area to be used in case you have an area that commonly used input files appear. Okay. And I believe exactly the same input systems are going to be used in Metafont. So once you solve this problem for TeX, you'll also have it solved for Metafont. Next year, your job will be a lot easier. Okay, have a nice break, and see you again at 11 o'clock.